Hello everybody, and in this video I will show you how you can actually automate the entire process of hacking Android and iOS devices. Now, in the previous videos we showed how we can actually hack some Linux systems. We also showed how we can hack all Windows systems as well, and I also showed you how you can run the attacks over the internet. But right now let's see what we can do with the Android attacks, for example. So if I just open up my terminal first, type in the root password, I will make this larger so you can see. And what I want to do right now is go to the Firefox. So just open up your Firefox. The tool is called Venom, I believe, or something like that. I already have it installed, so I will not install it, but I will show you from where you can get it. It is on GitHub, so you just do the simple git clone and then the link.git and you just run the program. It is very simple. So Venom, GitHub, right here, and you go to the first link as it says right here, GitHub Venom Metasploit Shellcode Generator. It is a very simple tool to use, so just copy the link and git clone it to your directory. As we can see, download install, the first part you need to do is git clone this link right here, then set files execution permissions to, so first change directory to the Venom and then sudo change mode -r +x all files. This basically star right here stands for all files.sh, and also the same do that for Python files. If you do not have dependencies installed, you can run the setup.sh, and then after that you can run the main tool. So if you do not have all the dependencies installed and if you do not download the files to already be executables, you need to follow these 4 steps, or basically these 3 steps. The fourth one is just running the tool. So once you do that, you should be good to go. Let me just find where I downloaded it. Desktop. Or we can just locate Venom. Simple as that. So locate Venom. Or maybe it's not the... Okay, so it is in Python files. Okay, so change home, user, desktop, Python files, Venom. So here you will have these same files right here. If you already ran the entire installation process, all you need to do is run this venom.sh file. So you do that with /venom.sh, and this will open up the shellcode generator. Now the first thing that it will ask you is to input your IP address. Now if you do not know your IP address, you can just check it with ifconfig. I know mine, so it is 192.168.1.15. Oops, 15. Click here, enter, and it will open this welcome box right here with the banner. Press enter to continue. We press enter. It will ask us which shellcodes do we want to generate. Now as we can see right here, it doesn't only generate the Android and iOS payloads, it can also generate the Linux, Windows and multi-OS payloads. Now since we already covered all of the other ones, we will just cover the Android ones and iOS. So just click here 4, which stands for basically both of these. So just click 4 as a category number. It will say loading Android iOS agents. Now since I don't have the iOS mobile phone with me, I will go with the Android attack. So choose agent number. Agent number 1 is the Android, so just check here 1. It will ask you for your IP address once again, since it is specifying it in the interpreter as the lhost, which is your listening IP address, which is in my case 192.168.1.15, and right now we specify the shellcode, the listening port to be 4444. Enter payload output name, example shellcode, so we can name it anything we want. Let's just name it as they say, so shellcode. And this will open up this shellcode generator, which will generate the shellcode for us. As we can see, some of the settings down below are lport and lhost that we set, and payload that we use is Android Meterpreter Reverse TCP. Now you might notice that you can actually use this payload in the Metasploit framework as well, so you do not have to automate this process with this tool if you do not want to. It is just a lot easier since it does everything for you. You can create the payload with the MSF Venom and then run the multi-handler as as a listener on your Metasploit framework console and perform the same steps as with the Windows exploits, for example. So you just set these options right here and check the payload to be Android Meterpreter reverse TCP. So let's see what it asks us right here. Payload stored in home user. Okay, so it made our shellcode. It is in this directory right here as the shellcode.apk, which is basically the application which is going to run on our Android device. So what we want to do right here is, do we want to set up a multi-handler by default or Apache 2 malicious URL? So what we want to do is basically set up Apache 2. Or you can go with the multi-handler as well. I will go with the Apache 2 right now. And it will start up by default our listening. As we can see right here, it set all the options, the L host, the L port, the Android Meterpreter reverse TCP, and it is started reverse TCP handler on 192.168.1.15, which is my IP address. So if we go right here and visit my Apache 2 or my IP address, my Apache 2 web server, so 168.1.15, and we go right here, as we can see, as soon as I typed in my IP address, it asks me to download the shellcode.apk file. Now, of course, I will not download it on my laptop since it won't really work, but we can see that the download is automated. So as soon as you visit this, the process of downloading is automatic. So you can basically spoof the local area network and make everyone redirect to this page, and maybe some of them will actually download this program, but that is not that smart of an attack. So let us actually, I will now open the application from my mobile phone. So let me open up my mobile phone. I will type in the IP address. I will visit it, and as soon as I do, it says this type of file can harm your device. Do you want to keep shellcode.apk anyway? Now, maybe if you were able to perform some social engineering attack, maybe they will click here OK, and shellcode.apk downloaded in Chrome. Now you can see what I'm doing on my mobile phone, but currently I'm downloading the application. Now, the most suspicious part right here is when it asks, do you want to install this application? It will get access to modify system settings, take pictures and videos, modify your contacts, read your contacts, access all of the stuff, record audio, read your text messages, modify or delete contents of your SD card, directly call phone numbers. So that is everything that we can do with this application. And if they click install and install the application, Playpro does not directly install anyway. It will say that the application or the mobile phone doesn't recognize this producer of this application. You just click OK and open the application, and as we can see, as soon as I clicked open, we got the Meterpreter session 1 open. So in order to check out what your available options are with the Android payload, you just type here, whoops, not get UID, you type here help. Let us enlarge this window so we can see it a little bit better, and you can see we get some of the additional components to this instead of that we get some of the more options than in the previous exploits, such as check root, dump call log, so we can get the call log, dump contacts, dump SMS, we can read all of the SMS messages, geolocate, send SMS, so we can actually send SMS. If you just type right here, send SMS, it will tell you the syntax for sending the SMS. So the send SMS -D for the destination number, so you just select the destination number, and -T for the target number, so you can actually send the SMS message from that phone to someone. And this is the T for the SMS body text, as it says right here, so this is the message itself. You can also play the audio, which we can do on Windows as well, and all of this is the same as before. Grab screenshot, shell, execute, get UID, so you can see that I really am on a mobile phone. As we can see, server username, this is the name of the mobile user currently. And you can do all of this stuff if you wanted to. You can record microphone, you can go into shell, local time. So basically these are the these are the important commands, or the new commands that we didn't cover. All of these are the same as in other exploits. As we can see, the 100 commands are right here, and you might want to actually check out some of these. We will not be actually going through them. There is really no point. You just click here the name of one of those, and it will give you the syntax to run it, and you just run that. So that would be about it for this Venom.sh tool. I hope you enjoyed it, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial. Now this will be the last video of the intermediate section. We have covered a bunch of other things such as web penetration testing, system hacking, man-in-the-middle attacks, wireless network attacks, and bunch of these things that you need to know in order to be able to call yourself an intermediate hacker. Now that is just a part of it. Of course you will need lots and lots of practice of all of these methods on different types of targets, and everywhere you basically can you need to practice them, since practice makes perfect. And in the next section we will finally enter our coding section. We will cover a little bit of Python and C. I will give you a small crash course on both of these programming languages. Now you shouldn't really expect to fully understand it from that crash course, since it will be short. I will only explain a few things. If you want to be able to fully follow that, you might want to search additional videos here and there for Python and C. But if you already know some of these programming languages, or basically any other programming language, it will be easy for you to understand this. We will be coding, as I said, our advanced backdoor in Python. We will try to replicate some of the options that, for example, Meterpreter shell has, such as screenshotting, keylogger, then coping files, persistence, so we can actually enter the machine whenever we want after the reboot shutdown and all of that things. We can upload, download files, and all of that interesting stuff. Now, as I said, you will need to know these languages in order to be able to follow this better. The crash course will cover some of the basics, such as some of the simple Python programs, some of the simple Python modules, C programs, and so on and so on. And after that we will actually start the coding of our backdoor and our other programs that we need. So that would be about it for this section. Hope you enjoyed it and hope you learned a lot from it. Make sure to practice it as much as you can, and I hope I see you in the next section. Bye! Hello everybody, and welcome back into the first tutorial of our actually backdoor coding. So what we will do right now is we will try to recreate some of the functions and some of the things that we saw in the previous section, which was the Metasploit or system hacking section. Now we saw that in order for us to run our Meterpreter shell on target, we had to actually set up a listener and run the shell on target system. So this is exactly the same that we will try to do right now. We will code two programs in Python. One will be the server, which will be listening for incoming connections, and one will be the payload or the reverse shell, which we have to deliver to the target any way you like, whether it is over email, over some message, over link, or if it is just a simply USB deliver method. So here I have some picture right here, so let me open it, which basically shows what we have to do in order to create the server and reverse shell. So there is a module or a library in Python called socket library. We will have to import that. We talked about in the Python basics what importing libraries mean and how they help us in our code production. And we will use that library in order to create connection between our PC and the target PC. As we can see, the server is a program that we will run on our Kali Linux machine, and the client is basically a reverse shell which we have to deliver. And these right here are just some of the functions that we will have to use in order to properly make a connection between these two PCs. As we can see, we will use a three-way handshake using TCP in order to make our program. We will not be coding an UDP backdoor. We will use TCP. These first commands, as it says right here, server creating listening socket, so we have to listen for incoming connections, the same thing as we did in the Metasploit framework when we used the exploit multi-handler and set up a listener on localhost and on local port. then we wait for target to execute our program, and then we get the interpreter shell back. Just in this case, we will not get the interpreter shell back, we will get the shell that we create. As we can see, as soon as the target finishes or executes this connect function, we will be accepting the connection and establishing connection via three-way handshake, and then we will be able to send and receive commands as long as we want. Now, another key thing to say right here is that we will use a while loop, which we also covered in Python basics, but right now what we will do is we will use an infinite while loop. We had a simple example of an infinite while loop before. Basically what we want to do is to be able to execute system commands on target PC for as long as we want, and then we should specify, for example, a command which is q or exit or anything like that, the string that we will type in order to actually break the connection and in order to close the reverse shell connection. So we will have to put these two functions on both of our codes or both of our programs in a while loops, so they can both send and receive indefinitely. As we can see, client sending the data, server receiving the data is when client uses send function and server uses receive function. That's how we will receive the command output that we run on target PC, and we run the command itself, or we send the command itself to the target via the send command or send function that is built into the socket library. As we can see, server sending data and client receiving data. After that, we have to, once we specify a q command or an exit command, depending on what we will code, we should be closing the connection with the target. So that's how we can close the reverse shell. Now, this is just the basic server and client type of program. What we want to do after we actually code the connection, we want to actually be able to execute some more things, such as, for example, running a screenshot on target system and actually getting that screenshot on our Kali Linux machine. Or, for example, running keylogger, or making a persistent shell, or making a registry key in order for us to be able to run the shell whenever system reboots or whenever target system reboots. So we want to build in all of those functions and make it as close as possible to the Metasploit framework interpreter shell. We will try to do that. Of course, we will not use all of the options in Meterpreter, since that would take too long to code and possibly would break somewhere, since right now we will not be running a properly written code. We only want to write a code that actually works. It doesn't matter if it is pretty or not for us, we want it to work and we don't want it to break. So, simple as that. Now, what I said before is that we actually coded the while loop for these instructions. Well, not for those instructions, but we coded something similar. So right now I'm in my Python programs. Let me just enlarge this so you can see it a little bit better. And let me just find which program was the while loop. Let me just cat one by one so I can find it actually. So possibly 6. No, those are classes. Cat Python 3. Maybe that is 4, so it's Python 4. So here it is. If I nano Python 4.py, here we can see a simple use of while loop that we will actually use something similar in our program. So we set the x value to be true, and while true we will run this program. So we will run it forever until the user types in q, which then after that will break the loop and exit the program. So we want to actually deploy something similar to this. So now, without actually delaying this, let's actually get started into coding a server, and a simple server and a simple backdoor for the beginning. So that will be about it for this tutorial, and I hope I see you in the next one where we start coding. Bye! Hello everybody and welcome back, and right now let us start off first by coding a server connection with the socket library. Now, before we actually begin, let me just tell you a few things. Basically, things will break from time to time, so don't let that upset you. or discourage you from actually finishing this code. At the end it should all work properly, but if you have some problems, make sure to check out on the internet. Basically some of the functions may be outdated on your Python version or something like that, and they may have a new name or a different name or something like that. Basically I will code right here in Python 2. But I will also sometimes use the syntax for Python 3 so that you actually can use this on both Pythons. But most likely some of the tools right here will be from Python 2, or basically libraries. So right now let us get started with our server coding. So what we want to do is, as I said in the previous video, we want to create a connection with the socket library. So let us do that. So first of all, let us make a directory for reverse shell. So let us call it reverse, and we have our directory right here, so we don't mix these Python basic programs with our reverse shell. So let's change our directory to the reverse shell, and let's nano our server. So we will start off with coding the server. So server.py, we should start off as in every previous video with the path to the actual Python. So hashtag exclamation mark then slash user share Python. This is something that you need to have included in all of your Python codes. And after that we want to import the library that we will use, which is called socket library. So import socket. Right now what we will do is we will basically create a simple connection with our server. So let us do that. We will use first of all, what we have to do is basically we have to declare our socket. So our socket will be IPv4 and it will run over TCP. Now the function that specifies that is specified like this. So we will type here s equals socket.socket and then open parentheses, parentheses, socket.af_inet, which basically stands for IPv4 address. So we want to make a server that will listen on IPv4 address, and then comma socket.sock_stream, which specifies that we want to have a TCP connection between our server and our client. So this is the beginning code of actually defining the socket itself, the socket descriptor, which will be written into the memory and actually accepting the connections after that. So this is how you do that in Python. It is very similar in other programs as well. So this af_inet and sock_stream is something that you probably saw if you coded some TCP servers in other programming languages as well. So after we do that, what we want to do is we want to set some of the options for our socket. So just follow up with me with s.set sockopt. I believe that is how we specify this function. And then what we want to type is socket.sol_socket, comma socket.so reuse addr, comma 1. So this is just some of the basic socket options. This socket.so_reuse addr basically allows a process to connect to a port, our local hosting port, even while it is in time wait. So it will make more sense later, but let us see our picture and what we have to run next in order to create our server. So we set up our socket with this command right here. We set up some of the options, so we specified our socket. Now what we have to do is actually bind the socket itself with, or basically bind the port that we will listen on, and also bind the IP address. So we have to specify the IP address that we want to listen on. Now in the process of actually creating this, we want to specify a local host IP address, which is basically same for everyone, which is 127.0.0.1. since we want to be able to run both client and both server from our Kali Linux machine. Once we actually notice that everything is running smooth and good and this program doesn't break, then we can switch the IP address to our local IP address or port forwarded, or basically a local IP address, or of the ngrok IP address if we run the attack over the internet. But if you run the attack on localhost, you want to have your local IP address in the s.bind function that we will write right now, and you can specify any port you want as long as it isn't used currently by the system. So don't specify a port like 80 or 22 or something like that. If you have SSH open, specify some random high port. So let us write the function which is bind, so s.bind. Now make sure that whatever you called your socket right here, which in my case I only called s, make sure to type it as well in other functions. So for example, if I call this sock, I would have to write here as well sock.bind and sock.set sock options. So make sure to follow up with that, so don't actually name something different and then use a different name later on. You have to use the same socket name for the entire program. So let us bind our port and our host. We do that with open double parentheses, so open two parentheses, then type here your local host IP address, which is 127.0.0.1, close the apostrophe, and we can see this is actually a string, so it is under two double quotes, and right now we want to specify a comma, and after the comma we specify the port that we want to listen on, which in my case I will just specify 54321. Doesn't even matter as long as the port isn't used by anything. So close double parentheses, and right now we were successfully specified our IP address, which is our localhost IP address, and our port that we will listen on. As I said before, this is something that you will change after we finish the entire program, so you can use it on any other machine. Right now, as we can see right here, the next thing we want to specify is the listening. We want to listen for the incoming connections, so you can do that with s.listen, and let's specify one in the parentheses. Basically means it will listen for one connections. If you specify two, it will listen for two connections. Let's specify 5 connections, so it listens for 5 connections. After we do that, let us actually accept the connection itself, and if you see right here, the accept, it doesn't show what it has to take, but basically what it has to take is the target and the IP address. The target is a sock, basically the file descriptor that it will store in memory, and the IP is the IP address of the target machine. So let us name it something like this. So target, comma IP equals s.accept, and you open and close the parentheses. Now in the accept function you do not have to specify anything in the parentheses. You can basically just specify the parentheses open and closed, which means it only uses function without the actual input in that function. So with this we get the file socket descriptor for our target, and it stores it, and we also get the IP address of our target, which we will use in order to actually print out from which IP address we received the connection. Right now we can save this program, as this is the most simple use of server. After we accept the connection, we can print, just so we can see that it does work, so print for example target, or target connected, then exclamation mark, we put that in the double quotes, and we can then close the connection, so s.close, and this is our server finished. So let's actually try to see if we can receive a connection with this program. It might break. I didn't double check this before, or I didn't code it before, so we will fix anything that actually breaks in our coding process. So one thing I want to specify right here is when it starts to listen, I want to print listening for incoming connections. So we want to print once it listens, and then we will try to connect with our other terminal, and if it connects successfully it will print target connected, and then it will close the connection. So let us save this, so Ctrl O, enter, and then Ctrl X, and then we want to chmod this so it can actually be an executable, and we want to run this. Permission denied. Why is the permission denied? bad interpreter. So let's see, user share Python. Okay, let me just see what are other programs. So cat Python 3 user, oh yeah, it's user bin Python, it's not user share Python, pardon me. So we need to specify, what was the directory name? Reverse. We want to specify actually user bin Python, it's not user share. So change this. Not really sure why I typed user share, probably because I was talking about Metasploit, and then Metasploit is located in user share. So just change this to user/bin/python, save this, exit, and now chmod it. We already did chmod, so we can actually run the server right now. As we can see, it just prints out right here, listening for incoming connections, so we know it performed all of those functions correctly, and now it is listening for an incoming connection. Now we can specify an incoming connection with a different terminal, so let's open up a new window. Let's actually enlarge this a little bit, so something like this. And right now, let us try to netcat on our local host. Not really sure if that's even possible, it should be. So nc, what is the 54321? And here we can see that we successfully connected to our program. As we can see, it said target connected, so we successfully connected to it and it closed the connection. So our server works, it can accept the connection and it will print out target connected once someone connects to our server. So good, now that works. So that is the most simple coding of the server. We will fix that code a little bit, add something here and there, and then we will continue with our client afterwards. Now in the next section, we will, or not section, in the next video, we will actually code the simple version of our reverse shell of our client, or basically our payload that we will deliver, which will successfully connect to our server.py, so we can run two Python programs and see if they interact well with each other. So that would be about it for this tutorial. I hope I see you in the next one, and take care. Bye. Hello everybody and welcome back. And in the previous video we saw that we successfully created a simple Python server that was able to actually receive and accept the connection from our different terminal. We were able to netcat on our local host on the specified port in the program, and it actually printed out that the target was connected. So what we want to do right now is actually, let us do something like this. So let us exit this. So exit. Whoops, I did not want to, I wanted to open Tilix. So let's open Tilix so we can split screen like this and run two programs. Yeah, I can close a terminal once I run Tilix, so let me just open it once again. I can lower this, enlarge this, and put it like this. Now let me just see. Let me just see if I can change a color, since the white one is actually a little bit too bright, but it seems that we can, so we will actually close this. We'll just run two terminals instead. So let us enlarge this like this. And let's use another terminal, so new window. We want to enlarge this one as well, so zoom in, and let us get right to work. Let's zoom this one in as well a little bit. Okay, so right here I will open up our server. Oops, let me just find it where it is. So cd python program, cd reverse, oops, reverse, nano server.py. Here we have our server, and here we have another terminal where we will code our client or our reverse shell. So we need to open up our server so we can see the different functions and the correspondent functions that we will write in our client for these functions in server. So let us actually go to the same directory, so reverse. Here we have the server, and right now we want to make reverse.py, or we can call it reverse shell.py. So we start off with the same hashtag exclamation mark, and then user bin Python. So this is something that you always need to include. And we also have to import socket as well right here. So this is the standard beginning part. Right now what we want to do is we actually want to connect to our server.py. Let's see how we can do that. So with this picture right here, we can see that in the previous video we coded some of these functions. We still didn't get the send receive function, but we will code that one as well. So for now on, what we want to do is actually create the client. So what we have to specify is the same as in the server, so we have to create a socket, and then all we have to do is perform a connect function in order for our client to connect to our server. So this is a rather shorter example of code than in the previous video, so it will be rather simple. We can write it in 2 or 3 lines. So let us do that. What we want to specify right now is the same as here, so we want to specify the socket. In my case, let's call it right here sock, so we can actually differentiate it, so we don't call it in both programs S, but it doesn't really matter. I will call it sock right here. So equals socket.socket, socket.af_inet, and then comma socket.sockstream. As we said in the previous video, this is just basically usage for IPv4 address and also the TCP connection for our server. Right now, all we have to do is perform the connect function to our server. So let us do that with the function sock.connect. And in the connect function, we have to specify where we want to connect. Right now, as we can see that we binded the port 120, binded the IPv4 address of localhost on port 54321, we will have to specify the same IPv4 address and same local port in order to connect to our program or to our server. So let us do that. So open double parentheses, same as in the bind command in our server, and here specify same thing. So 127.0.0.1, close the double quotes, comma, and then 54321. Then close the double parentheses. As we can see right here, the local port is not a string and the IPv4 address is put in double quotes, so make sure to not switch those up, otherwise it won't work. And what we want to do right then, we want to actually print that we successfully connected. So print connection established to server. This is just for us so we know that everything went good. And after that we want to close the socket. So sock.close, and we want to close the connection. So this is how this should go. Basically we run the server first. It starts listening for incoming connections. It prints out this line right here. And then we run the reverse shell.py, which will perform a connect function on our server. And basically what it will do after that, this target or this server will actually print target connected, and the reverse shell will print connection established to server, and both will close the connection. So that is how it should go. So let us save this. So Ctrl-O to save, enter, Ctrl-X to exit. Let's make it an executable. So chmod +x reverse shell underscore shell.py, and let's run the server first. So we run it with server.py, we get the string listening for incoming connections, and here we run the reverse shell.py. As we can see, everything went perfect, listening for incoming connections, then we ran the reverse shell, connection established to the server, target connected, and we closed the connection on both programs. So these simple 2 programs work. Now what we want to do in the next video is actually establish a longer connection where we can actually send some stuff to the other target. So we will see how we can actually do that in the next video. For now on, we successfully created a simple reverse shell and a simple server that only performs the connection function. And that would be about it for this video. Hope I see you in the next one, and take care. Bye. Hello everybody and welcome back. And in the previous 2 videos we actually created a simple server and reverse shell, and right now we want to be able to send some messages back and forth between these 2 programs. So we want to make a connection a little bit longer. We want to actually send some information from one program to another program and see if that will work. So let's start off with the server. So let us open server.py. As we can see, we opened everything right here. Let's in the other video, or let's actually open in the first video server, and in the second video we will open the reverse shell.py. So what we want to do right now is basically, first of all, we want to delete the s.close for now. So delete this. We want to delete that in the next one as well. We will perform the closing of connections at the end. And right now, let us try to actually send something with the send and receive commands. As we can see right here, the send and receive is something that we didn't code yet. So these two commands, both server and client have to have them. So one can receive and so both of them can both receive and send the information, or the commands in our case. So let us see how we can actually implement that. Let us start off by implementing it in the server. So what we want to do is use the command called use the function in the socket library called send. It is simple as that. So what we want to do right here, after the target has connected, let us see what we can do. We want to actually get an output from which IP address the target is coming. So let us see how we can actually give us a command line tool that will be able to give a user that is using the server a command line that will, where they specify a command and it sends that command to the reverse shell, which will execute it on the target machine. So let us actually make a variable called command. So simple as that. Command is something that we will send, and we want to get a user input for the command. So raw input, we covered all of this. We know what raw input is. It basically prompts user for an input, in our case a string input, and we want to specify what the user will see. So double quotes. Let's start with something like this. So star shell, and then let's try to create something simple as a root terminal shell. So hashtag, I believe it's something like that, then this sign right here, then the %s. The %s is actually the part of the string of the IP that we will attach to this string. We covered all of this in the Python basics. This is just before this shell, and then hashtag is basically something that you can specify anything you want. It doesn't really matter. I decided to specify that, and then we closed this as a string. After that, we need to attach the string of IP, and we can see, first of all, close the double parentheses, and we can see that the IP is something that we got with the s.accept command. So we will get prompted this string right here. Just instead of the %s, we will get written the IP address of our target machine. So that would be that for the command. Then we type any command that we want to run on the target system, and then the target system should execute that command. So for now on, we want to send that command right after we receive it. So we will do, since we specified here, we will do socket.send, I believe, or not socket, since we specified the target to connect, we want to send to the target. So we want to specify here target.send, and then the command. I believe this is the syntax. We will have to check it out, but it should be this. So this is something that this is a function that will send the input for this command to the target server. So let us see if we can actually receive something from the target server. After we specify the send command option, we want to actually receive data from the target system. And how we do that? We do that with the .receive function. So we will do something like this. So after that, target.receive, and in the parentheses in target.receive, we need to specify the number of bytes it will allow us to receive back. So here we'll specify 1024, since we will not really be needing much more than that. And that would be it for the server. Now this is a code for only executing a simple command and one command. So we will send a command, target will execute it, it will send back the output of that command, we will print the output of that command, and we will close the connection. So what we want to type right here is basically put this in, first of all we need to put this in a variable, so let's call it result equals target.receive, and then after that we want to print the result. So this parenthesis right here is something from Python 3, so in Python 2 you can use the print function both with or without the parentheses. I will use it with in my case. And after that what we want to do is close the connection. So this should be it for the server part of code. So let us double check. We got target connected, we got prompted to input a command, we send the command, we receive the results of the command, we print the results, and we close the connection. So let us code the part of the client command or of the reverse shell code. So let us do that. It should be rather simple and similar to the server, but right now we first want to receive the command and then execute it. Now to execute the command we need to use another library. So for now on we will not execute command, we will just try to send a simple string message, and later on I will show you how you can send a command and make target execute it. For now on let's just exchange some simple messages. So how we do that? Well, basically right here we will, or let's for now on, so you don't get confused, rename this to message. So it's not a command, it's just a message, simple message for now, so we have to rename it everywhere. Message, and that should be about it. And the result we will rename to the answer. Print answer. And here we want to first receive the message, so the message right here will equal the sock.receive. Here we receive the input message of our server, so we want to receive 1024 bytes, and we want to actually, what we want to do is actually send the answer, so sock.send, and we want to send, well, let's actually put it in a variable, so answer equals hello back. So this is something that the client will send back to the server, and we will print it in the answer, as we can see right here. So now we want to, in our client, we want to send this answer, so we do that with sock.send, and we send answer. And after that what we want to do is close the connection, so sock.close. And I believe this should work. Let us check it out. So let us double check. We get the command, we send the command, the target receives the command, it should print the command as well, so print message, then the target answer will be hello back, and then the target sends that answer, we receive it and put it in an answer variable, then we print the answer, then we close the connection, then the target as well closes the connection. So I believe this should work, so let us save, Ctrl O, Ctrl X to exit, and then Ctrl O, and then Ctrl X to exit. We first run the server, listening for incoming connections, good. Then we run the reverse shell. Connection established to server, and we can see that our string input actually worked. So we get the connection from 127.0.0.1 on port 45206. Here we will send, let me just move this a little bit so we can see it all good. Just a little bit more. Okay, good. And here we send hello. And we can see everything worked perfectly. Our server got an input of a message where we typed hello. We sent that message to the client, which printed that message in its terminal, and we can see it does match, so it is the same message. Then it sent the answer back, which we coded in the reverse shell, which was hello back, and we sent that to our server, which printed the answer in our terminal. And then they both terminated the connection afterwards. So we got hello back printed, and here we got hello printed. So that would be about it for this tutorial. We managed to send a simple message. We will try to make a code which will send infinite messages, or not infinite. We can send messages back and forth as long as we want, and then we will implement it to be commands that can be executed on target server, or on target machine. So that's about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and right now let us try to make our sending of messages infinite, or basically we will send messages back and forth until someone terminates the connection, and that someone will be the server. So let us open up our server in this terminal. We have the same code as from the previous video, so it is everything the same. I didn't change anything. So what we want to do, first of all, we have to create an infinite while loop in both of these programs. So let's start off with the server. First of all, let us delete the things that we don't need. Here we have everything, so we will use all of this. After the print target connected, we want to open a while loop. So we want to make it basically infinite, so we will do while true, which means that it will execute everything in the loop forever until the program is terminated. So we have to put everything right here in the while loop, so just tab it right here, target send message, answer equals target.receive, print answer, and then socket.close. Now socket.close you do not want to put in the while loop, since every time at the end of the while loop it will close the connection. So socket.close or as.close or however you named it should stay outside of the while true, basically outside of the while true loop. So here we also want to add something, so this should start off with the command or message in our case, raw input shell, and then we pipe a string input of the IP address and a local port to it. Now this is just something optional, you can just type here anything you want. I just type this so it looks prettier and so we can see from where the connection is coming from. Then we send the message, and what we want to do after that is actually have two different choices, which is basically on two different outcomes, which is basically if the message is anything else, we want to send it to the target and wait for the reply. If the message equals Q, just a simple letter Q, we want to terminate the connection. If we do not have that statement to terminate the connection, this while true loop will run forever, and we will have to close the program on the inappropriate wait. So we want to actually exit it properly. So after the send command, we want to run an if-else loop. So if message, which is something that we type, equals double quotes Q, close double quotes, and then two dots, we want to actually break out of the loop. As we can see right here, we break out of the loop, and then we can type here else answer equals target.receive, print answer. So let's see if this makes sense. We actually type the message itself, we store it in this variable, we send the message to the target. If message equals Q, this will close the program, it will break out of the loop, then it will continue to the next execution, which is as.close. If it is not Q, it will receive a target answer, it will print the answer, and it will go to the beginning of the loop, which will prompt us with the input of another message, and that will do forever until we specify Q as a message. So this should work for the server. Now let's see what we have to type for the client in order for this to actually work together. So for the client, what we want to actually first delete is the answer. Or no, let's actually make a chat program. So what we want to do is delete these two instructions. Here we have a message equals sock.receive. So we want to put both of those into while true loop. So let's see how this will do. While true, we run the same thing, then we tab these two, message equals sock.receive, print message, and then we leave the sock.close below. We do not want to put that in the while loop for same reason that we didn't want to put it here, so it doesn't terminate the connection in our while loop. So right now, let's see what we have to code right here in order for this to work. So we send the message, This will receive the message and it will print the message. So, good. Then afterwards we want to specify the message back. So this is something that we can do right here. The message back, let me just see if this will work. Yeah, it should work. So this is something that we want to do. So if message that we received equals Q, same as in the previous, we want to break the connection as well. Since if this server right here sent Q, it already closed this program, so if we receive a Q command, it means that the server has closed the connection, so we want to close it as well. Else, we want to actually get an input, so we want to send message back. We will call it like that, that is a variable, and then raw input type message to send to server, which is a little bit long, but it doesn't matter. So we get the message back, we get an input on our client to send the message back to server, and then we basically just sock.send the message back. Then after that it will go back to right here, it will receive another message, then it will print the message, and we can go on forever, I believe. So let us save this, Ctrl O, then Ctrl X to exit, same as here, Ctrl O, Ctrl X to exit, and then we run our server first, listening for incoming connections, then we run the reverse shell.py. We get prompted with this shell command tool, and we will just type here hello, and we can see that the client printed out our message, and it prompts the client to type message to send to the server. And we will type here hello or hi there. Let's just type here hi there. And we can see this works perfectly. We got the message back from the client which says hi there. Then we can say what are you doing? And the client will receive our question. They can answer nothing with the slash. That was a typo. So right now, let's say we want to terminate this connection and we type here Q. They both terminate the connection. Just right here it also prints the answer, which is not necessary, but it doesn't really matter. They both successfully terminate the connection. So our simple chat program works. So this is a simple code that we wrote in order to make a chat program. But you might be asking, why are we making a chat program? Of course, our reverse shell will not be prompted anything for the target to type. We want to actually execute the commands and not exchange messages between each other. So this will be similar. We will not change much to this, but this we have to change so the user or the target doesn't get prompted with the type message to send to the server. We just want to make the target actually execute the message and send the output of that message back. In our case, those will be terminal commands or command prompt commands. So we will do that in the next video, and I hope I see you there. Bye. Hello everybody and welcome back. And we successfully coded for now a simple message program which sends messages back and forth. Now just by simply changing the IP address to bind to and IP address to connect to, you can run this on two different machines on local network. Or if you do a port forward, you can run these two programs across the globe. But right now, we are not here to make a simple message program. We are here to actually make a reverse shell which will run quietly and not be detectable by the target. So we do not want to prompt the target with the type message to send to server. So let's actually make our reverse shell to be able to actually execute the system commands. And by system commands, I mean the command prompt commands. So if we type, for example, dir or something like that, we get a list of all the files in the current directory. So let's see how we can actually do that. There is a library in Python called subprocess which allows us to actually execute commands, terminal commands on the system with the Python. So let's use that library. Just type here import subprocess. I believe that's how you specify it. If it's not, we will have to check it out on the internet. And what we want to do is we want to first of all delete this. So if message equals Q, that should stay right here. So the break and Q stays right here. This is what goes away, so we do not want to prompt user anything. we do not want to use raw input on the client side or on the reverse shell side of the code, what we want to do is basically execute the command that we receive. So how do we do that? Well, basically we first of all receive the command. So we receive the command right here. So let us rename it into the command so you don't get confused. We do not want to print the command on the reverse shell, so delete this as well. Print message or command, delete that, and here delete the sock.send message back. So right now you should be having only this. We only receive the command if the command equals Q, so we have to change that as well. So not any more message. If the command equals Q now, then we break out of the loop. Else we want to run a rather long command right now, since that is the syntax for this command, which allows us to actually execute a terminal command or a command prompt command. We will call it proc as a process equals, and now just type what I type, subprocess.popen, so process open, and then we want to run the command, which is this that we received, and then comma shell equals true, then comma std out equals subprocess.pipe. We make sure to type capital pipe so it doesn't, I'm not really sure if it will work with the smaller pipe. Let us enlarge this so it all fits. Or let's actually just close this for now on, and let's enlarge this terminal. So we are only redoing the client right now. So else proc equals subprocess.popen, we run the command that we received, shell equals true, std out equals subprocess.pipe, and then after that stderr equals subprocess.pipe as well, and standard input also equals subprocess.pipe. So stdin equals subprocess.pipe. So we want to pipe that process or that result from the command that we received, and we will do that with the result variable. So we just create a variable called result, or call it anything you want. I will call it result in my case, and we want to call it proc.stdout.read, or not call it, we want to add to it plus proc.stderr.read. So we want to put both of these outputs of the command that we executed into our result variable, and all we have to do right now is actually send the result back to our target. We do that with the command that we already used, so sock.send result, and we should be good to go. So let's see, is there anything that we have to change in our server program? So this should be it for this, I believe. If it is not, we will add things necessary. So Ctrl-O to save, enter, Ctrl-X to exit this, and let's actually nano this server.py. Let's close it in the other terminal since we do not need it. So let's exit this for a second. Let's only use this terminal for a moment. And this is our server. So right now we send the message, which we also want to switch to command so we don't get confused. So command target send, we send to the target command. If the command equals Q, we break out of the loop, and answer, which will be the result, equals target.receive, and then we print the answer. So this should be good, I believe. So if you switched everything for the command, all the messages you switch for the command, and name the answer, rename it to result so it makes sense more, and print the result, don't print answers since we don't have the variable answer anymore. Right now you can Ctrl-O this as well, Ctrl-X to exit, and we can run the server. It is listening for the incoming connections. Right now let us open a second terminal, enlarge it a little bit, zoom in. Let us just make this a little bit more viewable. So let's split this into two. Let's also add this one here. Okay, so this should be good. Right now, let me just switch my directory to where my reverse shell is, and I run the reverse shell. So we successfully got connection established to server, and right now what I want to do is first of all move this so we can see both of the terminals. And right now I should be able to execute commands in a terminal. Let's see how will that work. If I just type here ls, we can see that we successfully got back from the other terminal, we got back the contents of that directory. If I just type here who am I get back root, so I am the root user. If I were to, for example, type here reboot, it would restart my machine. So we successfully were able to create a program that actually executes the command or commands, terminal commands and command prompt commands on the target machine. So we successfully created this most simple version of the reverse shell. This can also be dangerous, and it can also be used to change some things on the target machine, especially if they run it as an administrator or as the root user. So let's see what else we can run. pwd ls-la. But you will notice if I, for example, run a code for the ifconfig, okay, so for this as well we get the full output, but you will notice that we only specified the receive function to receive 1024 bytes. But what happens if we actually try to receive more bytes than that? That will actually crash our program. So what we want to do, we want to actually be able to send as much data as we want and receive as much data as we want. And we also have to fix some bugs such as this one, where I just press enter and don't send anything, it just bugs out. As we can see, it is waiting for a reply, but our reverse shell doesn't know what to reply with, since the command that it received was just nothing. It wasn't anything, but just an empty space, so it can't execute that command, therefore it can't send the answer back to our server. Therefore they are both hanging on waiting each other's requests. So that's something that we also have to fix. There are many things that need fixing here, but this is pretty good for our beginner reverse shell. Now we have to fix it a little bit, add some of the functions here and there, fix some bugs, and then we can continue adding different options for our reverse shell. So that will be about it for this video. I hope you enjoyed it, and I hope I see you in the next one. Bye!